So let's start. So we were basically seeing the basic fundamentals of Java, and one of the part is the variable. So basically, when we declare a variable, other than different than the Python, we should declare its type, and also we should give a name. And always we should choose a meaningful name, and probably you have also heard it when you're learning Python, but I want to emphasize on this. Like, we don't give the names like X, Y, Z or something, but it is actually for us to make the code readable. And also in this course, always please think about that your codes always will be a really large code, a professional code. It's not like for this course. So the things that you learn actually is not for some simple applications that you have only 50 lines of code. No, in a 50 lines of code, probably even though you give a bad naming, that would be okay. You can just figure out what it means. But if you have 10,000 lines of code, and if you didn't give a good name for the variable, then that might be really problematic. That's why actually all of our motivations are actually for the big projects, not some small course projects. And when we are declaring a variable, like we say int total, then the semicolon, we mean that, okay, we have an integer variable, we should declare that it's type first. And now what we are doing is that we are calling memory and saying, okay, I need a reservation, like a restaurant, and then says how many chairs you need. We say, well, I need 4 bytes. So integer is 4 bytes. So actually we are reserving a room and a place in the memory when we declare a variable. And by declaring its type, actually it is important because it also, then the Java knows that how much space needs in the memory for that variable. And if you need multiple variables to declare, well, you can either write them in separate lines, or you can also write them in one line. And when you say that, it means that all these count, temp, and result are all of them is actually an integer variable. So we can do it all of them in once, but you should now put a comma instead of semicolon at this point. And for the variable names, again, when we are giving a name, actually, it is for us to read even after 6 months, or for the other people to read. Again, what is the motivation here is that, like, you get into a company, they are already working in a project, and then you dive into a project, and then they give you that, okay, this is our continuing project, we have already all these codes, and you need to update this, there's a problem with this code, I don't know, you have to make it efficient and so on. Then, well, you should be able to read the code. And this part is actually more important in the ChatGPT era, that you should be able to read codes and understand, because so many people just generate it, but still it needs to be reviewed. So why do we give good names instead of saying TR? If it is about sales tax rate, again, we have to be more explicit so that people will understand what we meant by that variable. And conventions, the tradition in programming, we pay a lot attention to this. Why? Again, programming is actually a teamwork. We have to, and we are dealing with many big things. We have to be imagine things, but we don't want to be thrown in technical details. I don't want to confuse my mind with little details, okay? So it is really important to follow conventions in programming. What are those? Well, variable names start with a lowercase. Theoretically, you can start a variable with an uppercase. Java, the code will still compile. But actually, as a convention, in a tradition, we use uppercase as the first letter for the class names, not for the variables. So this is important. Like, if you do this mistake, I mean, you might, I don't know, maybe lose even a point. The reason is that if you give a variable name with an uppercase letter, okay, in your code, then you share your code with the others, okay? Then the software developer thinks that, okay, this starts with an uppercase, so maybe he meant a class, not a variable maybe. So unnecessarily, you will confuse the other people, or maybe yourself. That's why following the tradition is important. For these type of skills, we don't want to be uh, I don't know, creative and so on, we really need to follow these kind of naming conventions. And for the primitive data types, so what is this? Well, so this is actually in Java built-in data types. There are not many, like quite short, int, long, float, double, boolean, char. So these are not classes. These are not objects. When we start to discuss objects, this will be maybe more clear for you. But these are primitive data types. You do not treat them like an object. What it means is they don't have functions. They don't have their own functions. They don't have their own attributes. But they just keep some values. And well, since you are now a computer scientist, I don't think that this is a technical detail. You should be also aware of the data the size of the data, each of these types. Like byte is 1 byte, short is 2 bytes, integer is 4 bytes, long as 4 bytes, long is 8 bytes. Sorry, integer 4 bytes, double is 8 bytes. Why is that important? Let me do it in this way. Think it this way. You want to create an array of floats. You'll just keep numbers, okay? But your array size is 1 million. Now, and your memory, now, how much space you will need to keep 1 million integers or 1 million long numbers or 1 million float numbers or short numbers. So actually now you are giving a decision, because if your memory is not that high, but if you are unnecessarily using some numbers that requires more bytes, then you might end up with some excessive memory usage problem and lack of memory eventually. So you might also need to think about that. Okay, what are our resources so that we want to use it accordingly. And also the other thing is, each of them has a limit. Like what it means, let's say the number that I will play with is like, I don't know, 10 billions or 100 billions. Then will integer will be enough to keep it? Well, they have a limit. We cannot keep all numbers in integers. If you check that, it's basically thousands, millions, and billions. So you can only keep at most roughly 2 billion numbers. You cannot keep if your number is 3 billion, you cannot use it in integer. Then you have to go with long. Then you have to use the long numbers, because its number is actually pretty huge, like thousands, millions, billions, trillions, and like almost 10,000 trillions. So if your number is between 0 minus 10,000 trillions and from to positive 10,000 trillions, then long number is enough for you. But you should be careful about this. Like, because why? If you are always dealing with some small numbers, you know that, okay, a short will be enough. Then go with that, because its memory usage is much less than the others. So that your program will be probably faster and so on. So also, it's important to know the limits of these numbers. And when we are declaring these, again, we just write the primitive data type and then our variable name. Do you have any questions so far? And again, this is if we want to keep only some whole numbers like 5, 10, 100, then again we can use byte, short, int, or long numbers. But if we need a decimal number like 2.5, 3.17, and so on, then we can go with either float points, float numbers, or double. Now, what is the difference between these two things? Well, double is more precise in terms of decimal points, because it allows you 15 decimal points. So literally you can say 0 point and then put some 15 numbers. But in the float numbers, you have only 7 numbers. So if you want to be more precise in terms of decimal points, you can go with the double. Otherwise, float might be also enough for that. But these also doesn't mean that they cannot hold whole numbers. You can also keep store like 5, 10, or all these kind of whole numbers also in these data types. And when we are assigning a value to a floating point number to any variable, if you just write, okay, 29.75, okay, then Java will consider it as double. The default value will be double. So what does it mean is, if I said, okay, float number, so I declare a float number, and then I try to assign it to 23.5, then the Java will give you an error, a compile error. It will say, okay, you cannot do it. But it sounds weird. Why is that? Because Java thinks that this is a double number, but this is a float number. So in order to fix this problem, we also have to say that, okay, by 23.5, I meant actually a float number, so I put an F here. So 23.5 F, then Java said, okay, this is a float point. Now your code is valid. And for the numbers, Java uses this for the scientific notation, uses this E notation. What is that? Firstly, what is a scientific notation? Well, if you have these decimal numbers like 247.91, in a scientific notation, what you do is actually you just leave one digit here after the point, at the left side of the point. But for the decimal part, you leave all the others in the decimal part. But then, to make this number, to make this equal, you have to multiply it by 100, so that this will be also same to 247.91. Similarly, if your number is like this, 0.00072, its scientific notation will be 7.2 and then 10 to the power minus 4. So this is the scientific notation. And in Java, you will see the scientific notation with this E notation. How is that? So 2.4791 is actually 2.4791 E2. What is E2? 10 to the power 2. 10 to the power minus 4 is E minus 4. 10 to the power 6, E6. So basically, if you see this kind of number, it means that it is a number written in scientific notation. Do you have any questions so far? The other one is the Boolean type. So we have, as you know from the Java, Python, so I'll just go a little bit fast. You can keep either true or the false values in Boolean data types. The char data type is basically to keep a single character. So you have to be careful about this for 2 points. The first one is when we are declaring a char, it is not a string. A string is a different thing than a char. And how do we know it? Well, for the char, we use a single quote. But for a string, we use double quotes. If you put a double quote and A, you will say that, okay, it's only one character. But from a Java perspective, it will be a string. But if you use a single quote, it will be a char. And then, chars are actually, like as an example, let me first show this. You say char, upgrade, and then equal sign. Between single quotes, you can write only a single character. And also you might think, okay, chars, well, probably it's only one byte. This might what you might think, because it's only one character. And from a Java perspective, actually, chars are actually integers. They keep it like a numerical values. What does it mean? Well, eventually everything should be kept as a number in computers. But how do you keep A, B, I don't know, dot, exclamation mark, all of them are characters. So what we do is actually, we use an ASCII character, ASCII mapping. What is ASCII? American Standard Code for Information Interchange. So for each character actually, in this mapping, there's a number that is equivalent to that. Like for A, for instance, it says 65. For B, it says 66, and so on. So for each character, there is a mapping. And, well, But to do this mapping, we need two bytes. This is the reason that for each character, we need actually 2 bytes, not a single byte. And how do we keep it in the memory? When you say A as a character, A in the memory, it is kept in a 2 byte as like this. So 2 bytes, the value of A is 65, the capital A is 65. So 65 is 1 byte, the other byte will be remaining 0. And then we keep it in this memory. What is this? What is a 0, 1, 1, 1? Do you know what it is? Binary numbers. Okay, what is and what is the equivalent of this? Have you ever taken? It's in the binary digit number. So if you do the calculation, it is base 2 numbers, 1 plus 2 to the power 1 to the power 2 to 3, 4, 5, 6 to the power 6 is 64. 64 plus 1, 61. So basically, this is a base 2 number representation of 65. So that's why it is how it is kept in the memory. Is this important? Well, let me say it in this way. When we start to deal with write data in write binary data and read data from binary files, yes, this part is important. We have to know how each data is actually have been written in the data, in the memory, in terms of byte schedule, because when we are reading to binary files or reading to binary files, yes, we have to know this. Okay? But do you have to memorize, okay, what is capital A in ASCII character? No. You don't need to memorize it. Please don't do it.
It's already saved somewhere in the internet.
Yes, yeah, so, yes, exactly. I mean, you can easily find the value of these characters, so I don't think that you should memorize it. Keep your mind for more important stuff, okay? And variable assignment and initialization. So we already said that, like, when I say int month, I say that I declared it, like I reserve an integer space in the memory. Then, by using this equal sign, I do then assignment. So month will be equal to the 2. Or I can do it in one line. I can say int days is 28. So I declare it and also exclude an assignment. Once I declare a value in a variable, then I can use that to in anything, like I can print it and so on. But if I attempt to use a variable without initializing that, I will get a compile error. Java will say that, okay, you reserved a room in the memory for this integer value, but you didn't assign any value, so it will not run. Do you have any questions so far? Okay, I would like to take the